And here was the picture in Russia, the isolation of virus in this season. You see the epidemic, the wave of epidemic started at week 42. In epidemiology of influenza, we count not months but weeks of a year, and it continues till the first week of the next year, 2010. Then it is a little stop because we have winter vacations, New Year and Orthodox Christmas vacations, 10 days. There is a very situation that people do not meet at work, at the institutes, at the universities, and so on and so forth. And then it was some continuation. At the end, we had a little prevailing of B viruses. But here, it was practically monoetiological wave of influenza. And here is, very briefly, not in details, the antigenic analysis. What is this antigenic analysis? When we have anti-sera and we have strains, we make this hemagglutination inhibition test, and we estimate how much is the difference of titer between the reference strains, homogeneous titer, when the anti-sera to, for example, for this reference strain, California, it is with the same anti-sera to this strain. How far is the difference? So, for example, here we see that the anti-sera to California reacts with the same strain at 640 titer, and with the strains isolated in different towns of Russia, mainly from St. Petersburg, thou the same titer, thou one half of this titer. So this is practically no difference. If the difference is less than 1 to 8, the titers are judged very similar. So what is interesting, that here is the reaction with anti-sera to reference strain California. St. Petersburg strain was chosen by us as an inner standard, but it is interesting that the pandemic viruses reacted also with anti-sera to New Jersey virus, swine origin virus of the year 1976. And even there was a reaction rather substantial with anti-sera to swine line virus of the year 1931. So 70 years has passed and there is still cross-reactivity. So we can postulate that at least the hemagglutination of swine influenza did not drift too much since many years. And here is the phylogenetic tree of hemagglutination of pandemic strains isolated in Russia. The strains here shown in red were sequenced at our institute. Here is this New Jersey virus, very ancient one, and by green shown two reference strains, California 0Z09 and Texas 0Z09, which are the components of pandemic vaccines. And here by this symbol is shown the mutation about which we will talk a little bit later, and which is responsible maybe for the growth of pathogenicity of virus. This is the same phylogenetic tree, but for the Neuraminidase. For the Neuraminidase. Here, I apologize. There are some words in Russian I could not change them. This is a pandemic influenza. This is the swine avian-like influenza, the classical swine strains, and seasonal H1N1 strains. It is interesting to discuss in a few words the pathogenicity of this virus, pandemic virus. Here are presented several determinants of high pathogenicity which are present in H5N1 avian virus. I will not talk in detail, only for example this cleavage site of highly pathogenic type, which is enriched by the basic amino acids like arginine and lysine, and which is very easily hydrolyzed by cellular proteinases. It is typical to highly pathogenic avian influenza. And you see, only I wanted to show you by this picture that all established determinants of high pathogenicity at genetic level are absent in this pandemic virus. So from the molecular genetic point of view, pandemic virus H1N1 is moderately pathogenic. It's not so pathogenic as H5N1 virus. Let's speak a little bit about these mutations. A mutation of hemagglutinin position 222 when aspartic acid is changed to glycine. It leads to the enhancement of the affinity to alpha-2,3 sialyl galactosides, which are characteristic to lower respiratory tract. As far as we talk of these receptors, of glycoprotein receptors, the receptors of human type of the higher respiratory tract are alpha 2.6 sialyl galactosides, and human viruses are the affinity to such type of receptor. While these mutations leads to the more adhesion to 2,3 sialyl galactosides, and it can grow the receptor specificity and then aggravate the disease. And we have found that about 26.7% of Russian isolates have this mutation, but we did not find clear correlation between the severity of cases and this mutation. Such viruses were isolated from very transient diseases, from moderately cases, and from lethal cases equally. So there was not such a correlation. By now, the best measure of prophylaxis and the treatment of influenza is vaccination, which has surely its plus and minuses. The very benefits are the generation of specific immune response, diminishment of the severity of illness, reduction of probability of complications, and the degree of protection goes up to 80–90% if the strains, if the vaccine strains were chosen properly. Though there are several gaps, such as impossibility to design a vaccine before the appearance of actual strain, the need of essential time for the production, not less than 6 months, and with all regulations it goes to up to 9 months, restricted production capacities, and finally the need of annual revision of strain composition because of antigenic drift. Each year the WHO has two conferences in February for the next epidemic season in the North Hemisphere, and in August for the next epidemic season in the Southern Hemisphere. Now we have in all types of vaccines, we have 3 strains. One strain for H1N1, one strain for H3N2, and one strain for B. We cannot augment this quantity because the protein charge of vaccine cannot be too high. The less protein, the less it is reactogenic, this vaccine. The good production practice is that the vaccine, one dose of vaccine should not contain more than 15 micrograms of protein. So for the 2 seasons, for the season which just finished and the next epidemic season, the composition of vaccines was not changed. There is one component of pandemic influenza, this strain California 7, or very similar Texas 5. This is pandemic component. Perth 16 is H3N2 component, and B Brisbane 16 is B component of Victorian lineage. There are 2 lineages of B virus, Victorian and Yamagata lineages, which circulate separately or at the same time. A few words about preparations for the treatment of influenza viruses in Russia. I showed you this picture because it's somehow different from what we have in Western Europe and the United States. First, ethiotropic preparations. These preparations act for the specific mechanisms of virus and cell interaction. And the most ancient of this type of drugs were blockers of ionic channel. These are the derivatives of adamantans. In Russia still is used rimantadine, and 2 polymeric forms, algerem and orgerem. These are the forms of rimantadine on the polymeric matrix of alginate of sodium, which acts as an adjuvant also. The second generation of ethiotropic preparations are the inhibitors of neuraminidase. We have oseltamivir in tablet forms per os, and zanamivir, Relenza, spray forms for intranasal. And finally, we have also the third form, peramivir, which is not yet broadly used in Russia, for the very heavy forms for intravenous injection. For one single injection, we have peramivir. But this drug is not used in the Western countries. It's specific design of Russian pharmacologist, Erbidol. This is inhibitor of fusion of virus with the pegalisosomes. It is used only in Russia, and now it is starting to be used in some countries, maybe in China. But we also have very big repertoire of preparations of interferon, which are not specific, but which help organism to resist to viral attack. Ingaron, alpharon, reaferon, these are the production names of interferons, of molecules of interferon, and inducer of interferon. The preparations which can enhance the synthesis of interferon in the cells in the organism, such as cycloferon, amyxin, Kegel cells, and then the symptomatic. And surely we cannot deny the usage of antibiotics, because if we have a severe case from the 3rd or 5th day, when the fever syndrome temperature does not fall, one should start antibiotic treatments, because such severe forms are very often accompanied by secondary bacterial infections. especially Stephenakov.